Hi everyone, I'm Kelly Kay from Josephson Engineering. We're here at MESSE 2014, showing our line of microphones. I'd say our flagship mic here is our C700S. If you see, it actually has 3 capsules, a forward-facing figure 8, a forward-facing Omni, and a side-facing figure 8. And if you know anything about mid-side microphone techniques, this microphone actually has an output for each capsule, so it's almost like 3 microphones in one. And with the 2 forward-facing mics, you basically track these capsules, and after the fact, you blend them together and create different polar patterns. So with the forward-facing 8 and Omni, if you were to say, for instance, blend 50-50, you'd have a cardioid. And then you would introduce the figure 8, and you could introduce it in phase and out of phase and create a left and right channel that you could steer based on how much of the side-facing capsule you blend with the forward-facing capsule. So the different thing from a mid-side mic is that you can actually control the mid-mic after the fact, not just the steering. With a typical mid-side, you're forced to pick a polar pattern that you're steering, and it skews slightly as you steer it. Here, you can get exactly what polar pattern that you want and exactly what angle you want after the fact. In fact, we don't recommend people even try to figure out what polar pattern and what angle they're getting, because it's kind of liberating. You just sit there and do your mix, and what's really important is how it sounds. So you can balance the stereo imaging with the tightness of sound later on when you're doing your mix down, which is the most important time, rather than guessing what you would want ahead of time, and maybe it's in the ballpark, maybe it's not, but with this, you're good to go and make adjustments later. In fact, if all you really want to do is make a stereo recording with the C700S, we still recommend that you save the 3 stems, because if it's a great success for you and you want to revisit things later, you could actually use the channels from the 700S to create a sound, surround channels as well. A center, a left front, a right front, a rear, left and right as well. The exact same way that you would create the left and right channels for stereo. So moving on to our other microphones, our latest microphone, actually, although it's a couple of years old, is our C716. And before I get too much into this, next to it is our C715. And if you look at these, they look very similar. An important part that I should tell you about both of them is about the head basket. This isn't an end-fired mic like an SM7 or SM9. This is a side address mic, and what looks like foam is foam, but it's metal foam, and it's dip brazed. So basically this basket, which is metal, and this body, which is metal, are held together and lowered into a bath of metal that melts at a slightly lower temperature than the body and the basket, and they're fused together. So this is one continuous piece of metal. And the basket really looks like windscreen foam, but it's made out of pure aluminum. So it has structural integrity. You know, if you were a brute, you could crush this, but it would be much more difficult to crush than, say, a typical, wire-screened basket. It's very strong, but it's very strong without having to have any sidebars or any headband. And even then, where the screen is in this really is this foam structure. So rather than having it all concentrated in the plane, it's staggered over in space. And so we know from acoustics, if you're building a recording studio, you never want to have parallel sidewalls. But if you look at most microphone head baskets, they have parallel sidewalls. They have the hard walls, which are the struts that hold the basket up, sometimes a headband, which is a solid hard wall. But then they have, a percentage openness screen, which is partially reflective, partially open to let the sound out. And the reflective part really is a parallel sidewall with the rest of the basket. So you end up getting these resonances. And if you were thinking about a studio, you measure the distance from the walls, you know that it's sound in air, and you can calculate the wavelengths. But for a little room, if this were a small studio, it actually corresponds to the frequency range of the 3 different sibilance types, the and which are areas that you'd like to equalize. And if you want to equalize them, and if they're typically harsh areas as well, you don't want a ringing to make it more harsh, and on top of that, you don't want these spikes or resonances that are going to mean if it's has a narrow Q over a sibilance and you want to adjust it, when you bring it down, you're going to have a W. So for those two reasons, not making it harsh and making it possible to EQ after the fact, you really don't want resonances in the sibilance range. In fact, if you look into discussions that people have about microphones, one of the things that comes up is people say, they're proud to say things like, this microphone takes EQ well. If you really dig into that, you'll find most of the time they're talking about most of the time they want to EQ, it's around some sibilance, and they can't really do anything because the basket's ringing, and you try and EQ and you make things sound weirder. Maybe you make it less harsh, but you end up having two holes in the frequency response. So with this basket, you don't have the problem. Now, getting back to the fact that this is actually a model of mic, there's two, and this is the most recent one, the 716. This is different from this in that it has a large dual diaphragm capsule in it, and it also has a solid state output circuit. Its brother that came out a couple of years beforehand is different in that it has a large single diaphragm capsule and a transformer output, a large nickel core transformer output circuit. And so when you have dual diaphragm versus single diaphragm, this is something that people overlook. They just think large diaphragm. But if you go back into journal articles, really technical writing about capsules, and there's in fact a great paper written about 13 or 14 years ago by two researchers, Guy Torrio and Jeff Segota, about the difference between a single and dual diaphragm capsule. And they found that they could model it and test it, that the single diaphragm actually has more proximity effect. So as you get closer and further away, the bass swings up and down with distance more extremely than the dual diaphragm. So that can both be, that can be played to your advantage as a tool when you're selecting a mic. If you wanted to be a voiceover person and get that deep, growly voice, you get up close and you can do, hey, how are you doing? Or if you're a very thin, squeaky female singer and you need some more, foundation or lower end to your voice, a microphone like this would be good for you as well, getting up close. On the other hand, if you have, a perfect voice, crystal clear, good low end, you wouldn't necessarily want this. Maybe you're a fantastic opera tenor and you like your voice exactly the way it is. You'd probably prefer the dual diaphragm. And so we have people compare these and they universally come out and say one is not better than the other, they're different. And if you have them both together, they cover all your bases. Now back to the 716 with the dual diaphragm, it has a solid state circuit, and we think that pairs with the dual diaphragm in that less proximity effect, more neutral, makes this more of a this is the way it is microphone. And this having the single diaphragm, so more proximity effect to be able to play to raise the low end, or if you get very far away, get less low end. You also have the nickel core transformer to give it character or vibe. So if you really want to be that beefy, disc jockey or the kind of person that does voiceovers for movie trailers, hey, coming out soon with more explosions, you'd take a micro like this, it would smooth out your voice so subtly with the transformer output, a little bit of nickel core transformer vibe, and give you that ability to boost the low end. So two completely different animals. If you look at them and see them and see that they seem the same, they are not. And then this one with the single diaphragm, because it is single, we have the ability to open and close the back because there isn't a diaphragm on the back. And by closing it, we can actually get an Omni polar pattern out of this microphone. And then opening it, you get the cardioid. Now, naturally, most of the time, people will want to use that as a cardioid. The need for a large diaphragm Omni is not so great, but if we have this opportunity for a little effort to put that in there, it is actually useful, once in a while to have the ability to set this in Omni. Maybe you want to have 3 background singers sing into the same channel for, more minimalistic recording technique, sounding more natural. You can do that with this mic. So that's our 716. and 715. Now, I'd say our most important mic in our line as far as what's gotten us notoriety and what we're known for is this microphone here, which is our E22S. This mic was actually designed in conjunction with the recording engineer Steve Albini. You might know him from a recording called In Utero with a band called Nirvana, or a recording with a band called Pixies, many different recordings, PJ Harvey, Jimmy Page, Robert Plant. But I think also about 18 years ago, he came to David Josephson, the founder of our company, and said, I want a microphone that does this sort of thing. Not just that the capsule faces sideways, but he wants a good transformer output for a number of reasons. And at that point in time, no one was doing such a thing. He went to a few companies that had done it in the past, and they basically turned him down. But when he came to talk to Dave could see exactly why I wanted a microphone like that. And Steve Albini was actually involved in the development process. So Dave came up with different revisions of this mic, sent it to Steve. Steve would say, yes, but I needed to be a little bit more like this. And at the third revision, Steve actually kind of said, this is exactly what I want. And that kind of locked in what is now today our E22S. And so this is not only a single small diaphragm side address, but the important thing with this microphone is it has a large but sort of cocktail sausage sized met glass core Lundahl transformer. So very high grade and sort of high tech transformer in that Lundahl's known for super high quality, but this is met glass core, and not too many transformers use this met glass technology. And what met glass does is it allows you to make a transformer, but one of the things that transformers have is low frequency distortion, but the met glass transformers are basically the audio transformers with the lowest known low frequency distortion. So even though it gives you the benefits of a transformer, it gives you the least transformer vibe. So the closest to a solid state output sound, but from the benefits, still yielding the technical benefits of a transformer, which in the case of this microphone gives you a lowering of the signal, which at the same time boosts the headroom that you have to record to without using a pad, which, when it boosts the headroom, it also increases the noise. So if you had a traditional resistive pad in a mic, without the pad, you might have a noise floor here and a maximum SPL here, and then you switch in the resistive pad to give you more headroom, but you add noise. So you have this dynamic range or this dynamic range, but not everything. With a step-down transformer, you actually lower the signal, so you increase the headroom, but you don't add any resistance at all. It's just you're purely passing signal, and the noise floor stays as low as possible. So you have confidence that when you've got the lowest noise floor, and the max SPL that this can handle is 144 dBs, which I don't think that you're going to be wanting to do anything louder than that in the studio. You jeopardize the musician's hearing, for instance, right off the bat. You're not going to worry about, oh my God, I listened to that and I'm clipping the transient. So even if I don't distort the whole signal, if you're doing percussion, for instance, you have this massive millisecond transient, and then your signal, a lot of times you clip that transient and it doesn't sound like your whole signal is distorted, but there's something of the liveliness of the sound that's lost, thrown out the window. And you may not even realize that after the fact, but the sound quality is hindered by it. With this microphone, there's as good as no chance that you're going to have truncating the first transient in something like a loud percussive signal, and you're still going to have a clean rest of your signal. So, for instance, if you're a drummer and you have these on your toms or on your snare, and you want to play with brushes and very softly, and it's nice and quiet, you're going to have a very good quiet mic, and then switch over to some heavy sticks and start thwacking the drums as hard as you can. No problem. You've got quiet, you're not truncating any of your massive transients. And then so for a similar reason, we have lots of people that write to us and say, man, I use this on a loud Marshall stack. A lot of the music now today isn't full on loud distortion right away. Maybe quiet stuff with hearing the amps, the hum coming out of the amp, so kind of a little bit ambient, and then boom, loud as hell. and it sounds great for either. It's not a different mic for one or the other is better. This is a good quiet mic and a good ridiculously loud mic without blowing anything up. So, the only thing to pay attention is the overload light on the console, and as long as that doesn't flash at you, you've got a clean, unclipped signal that's quiet. And so we think this is unique in the market. Even if you're going to find a microphone that has a transformer, it's going to be rough to find one that's a small diaphragm, and even rougher to find a company today that's putting a high quality transformer like a Lundahl in a pencil microphone. So that's what we think makes this unique.
So for example, recording a triangle, which are notoriously difficult to record, that would be
this should be beautiful. It really should be great. And then after this microphone, these are our C42s. I can take this out just to show you. This is our basic entry-level pencil microphone. We actually sell these in match pairs, or we can sell single ones, which if you buy one, they come in an actual stainless steel body. There's no finish on it. The whole body is machined out of stainless steel. Or we sell these in pairs, and they come in a small Pelican sort of military use hard case, and they're matched. They're really matched properly in our anechoic chamber. We'll build them all, we'll number them, not with a sticker on them, but we'll put them in number trays. We'll do curves on them, and we'll directly match curves the proper way, and then we'll put the number stickers consecutively on them, the real matched pairs. And these are, each around $400 in the US, and less, I think, slightly less than $1,000 for a matched pair in a hard case with clips in the US. Off the top of my head, it's kind of rough for me, but I think US price, the 715 is around $3,700 US dollars, or the 16 is around 4,000 US dollars, and then our 700S is around $6,800 US, like street price. And then this is our last microphone, our C617 set. And sorry, I'll take it out too. And we can't take all the credit for this mic. We actually have worked with the German microphone company Microtech Gefell for a number of years. I believe like within a year after the Berlin Wall, Dave went over there, and we've been distributors for their measurement line, not their audio line, so lab equipment, which actually has a synergy with our company. Even though we're a studio microphone manufacturing company, our name, Josephson Engineering, does ring true to the fact that about 10 to 15% of the work that we do out of the company is actually acoustical consulting. Sometimes for circuitry design for other companies, sometimes for actual acoustic issues, maybe for audio, maybe resonance or building acoustics, but we do engineering work. So it was a good synergy with us to sell acoustical measurement equipment made by Gefell. And then I think it was about 15 years ago that Dave came up with a body that ran off of phantom power that could generate 200 volts, which is the polarization voltage required by these measurement capsules, which is not an easy thing to do. So this mic actually takes about 7 minutes to become completely stable, because it's actually taking the 48 volts and as consistently as it can, slowly pumping it up to 200 volts. And then without any special external power supply, you have the polarization for the 200 volt Microtech Gefell measurement capsule. And these are really great because they're actually a special grown nickel submicron, so less than 1 micron thick. I think it's 0.9 microns thick, pure nickel diaphragm, kind of like you'd find in the old Neumann M50s, but that's not a stretch because Gefell has its roots. At the end of World War II, where they broke off from the original Neumann company, and I believe that this technology came from those roots. So that's this microphone. It's basically a very high-end Omni recording mic. You would use it for recording symphonies or room ambience in a studio, anywhere that you would want a very high-quality Omni. And that's basically our entire line. We're based out of Santa Cruz, California. This is our 25th year in existence. So over here in Europe, you may have only begun to hear about us sometime in the last 8 or 9 years, but we're not newcomers to the world of microphones.